The first question I would like to answer is maybe you ask yourself why we did this project and from where came this idea of porting D3.js to Kotlin Multiplatform. Well, I think that the world is getting more and more complex and we'll have some big issues to solve in the near future. And to understand the world, its complexity, its data, I think there is no better tool than visualization. I knew D3.js and its ability of creating amazing visualizations, but I also faced its complexity and its steep learning curve. And because I also knew Kotlin for quite a long time now, I think it would be a nice opportunity to mix the algorithm of D3.js with the language features of Kotlin. Its ability to create nice DSL, to produce a multi-platform result, and to have a nice productivity when building data visualization. So basically, we decided to take D3.js and the modules of D3.js and to port them into Kotlin Multiplatform. So this project, and I proposed this project to Pierre, and I, as usual, said, okay, well, it's interesting, let's do it. So this was a year and a half ago, and we didn't present ourselves. So I'm Gaetan Zoritchak.
I'm Pierre Mariac.
And we created a company which is called Datavisualization, and we created this company just 6 months ago. It's located in Geneva, Switzerland. And so we started to create this library. We started 1 year ago, and the goal was to really do some isomorphic tool to have exactly the same rendering on each platform, and to build this library as an open source library. So the code is on GitHub. And what we did was to take each module of D3.js and to port it into Kotlin code. So for some parts, some module, we could port all the code into common code. So for example, here we have an interpolate module, so it manages functions, mathematical functions, to calculate the state of intermediary states, and during an animation you want to know at what moment your object is going to be at a certain place. And this code, because it's just mathematical function, could be completely done using common code. But for some other module, like for example the timer had a lot more need to be more linked to the platform. So, for example, for the timer, we had to write some JS code, but we tried to put the more code we could into the common part. And the most of the API is in the common part. Okay? And because D3.js is written, obviously, in JS, we started with the Kotlin.js code. And then after we started, we did the port of JavaFx, and we finished by Android. Okay, so now Pierre is going to explain you what's in a Dataviz library.
Okay, thanks. So what is a Dataviz library? Data visualization library is a complete set of components and functions, very low level, that you will use and compose to build and lay out your visualization. Okay? So let's have a look at some example we've done with our library, and let's see the module we are using to do that. So this chart is called a chord diagram. It's used to display the links between some of your domain objects. We also use here the thickness of the link to display the volume which link two of your entities. A chord diagram, to build this, you need to use several modules. Okay, you can just create a new chord, and it's not an object. You need to build it from scratch. So you will use a chord layout. You will use some basic shapes. You will use some color scales, to build these gradients, for example. This animation, it shows a line-of-sight algorithm. And to build this animation, you'll need some geometry function. You need polygons. You need animation, obviously, and shapes. This is a constraint network. It uses force, and each element, force repels each element each other. Okay? And so to do this, you use the force module, you use the tree structure, animation, timer. Last example shows an orthographic projection of Earth. This uses the geo module, which contains a lot of projections, to translate some coordinates into a screen position. And so to do this, we use the geo module, we use shapes, animation, timer. Gaetan told you a bit earlier that we have tried to do an isomorphic library. So we have put a lot of effort in this, and here you can see the exact same code running into JavaFx, and here in JavaScript. So as you can see, we have the exact same code, and it's running the exact same way on the free platform. Okay, so let's have a look at what is inside D3. So this is a complete list of the module of D3. We have grouped them to, because they have kind of such functionalities. So the first group are some modules in D3 that are built because in JavaScript you do not have the tools. So these are functions for mapping your data, filtering, sorting, so on, and a random number generator. And all this is already in the Kotlin standard library. So we did not have to port this module. Then here we have done a full group of module, color, shape and scale, path, polygon. This is used to create the most basic visual element of your visualization. Okay? So here everything is ported. Same for these two modules, is and interpolate. These are two modules which are used to animate things on screen. Then here you have a whole group of layout module. So axis, as its name implies, it allows you to create some axis, chord for chord layout, force is for having a force simulation. So we have ported all these modules. We also have ported timer to help you, time your animation principally. And then you have 3 modules, 2 for formatting and 1 for time. We had to port this time module in our library. As right now in Kotlin, in multi-platform, you do not have access to some date and time functions. So we have done this. These are some remaining modules that we did not have already ported, and we intend to do this soon. These modules are for event interaction. So as we have a multi-platform library, event interaction on a device like a mobile phone and on a web page is obviously not managed the same way. So this we still have to build a great API, to have in the same API and can manage a very different event interaction. Okay? We learn D3, we know how to use D3, but we also think that D3 is hard. And so we thought, how can Kotlin and this feature help us to build and to improve the D3 API? So first was to give some better structure, better code structure, okay? On your left, you can see here some D3 code. On your right, you have the same function, but down in our library. And here you can see this is a pattern which is often used in D3, in which you chain calls. So you see there's 1, 2, 3, 4, 5, 6, 7, 8 chain function to select an element on your page, create a group, append your data, and for each data, create a group, circle, and set the attribute of your circle. So it's very hard to read. Here we have put some indentation, but this indentation has no real meaning. It's just here to make it easier to read. Inside this, there's no way the IDE can help you because you don't know where you are. And here you see that Kotlin has helped us to provide a better code structure. So here, we have a much more expressive code. We expressly iterate over our temperatures, so there's no magic binding like here. And in our loop, we create a group. Inside, we create a circle. Also, what you've seen here is that we have chosen to type everything. We removed all the magic of D3. On this function here, you see that the add function is for setting an attribute on your DOM object, here your circle. And you see that this add function can take a number, it can take a function, and can take a string, it can take an object, it can take a reference to a function. And D3 will do some kind of magic and will try to understand what's going on. Sometimes it will parse a string to a number. You see also that here it's some CSS grammar. You're directly setting a field value in your CSS. So it's very hard to know. You need to know CSS, SVG grammar. So we type everything, and here when we have a circle object, we have an X property, which is a double. We have a radius property, which is also a double. Inside the circle, we have a style object, which has a field property, which is a color. So everything is much more easy. Your code editor will help you. You just have to use the auto-completion. There won't be any error. If there's an error, you'll know it before compiling. So it's much more productive. You can see here that we also add some extension property to allow you to create some object on the fly. So here you have this extension property .color on an integer object that allows you to create a new color object directly in your code. Here, quite the same code, but we are adding a transformation on our group. So you see, like before, we use the add function for a transform, which has a function that returns a string. This string is built by using the translate keyword, which is a SVG keyword, parentheses 0. So this is totally, you can't understand. You must know SVG grammar, and it's very difficult to read. So what we have done is we have created a lot of micro DSL, like transform here. And when you're in a group, you will have auto-completion. You will have access to this transform function. And you open your curly brace, you will have access to translate or rotate, and everything is typed. The translate function will take two numbers and will translate your code. So it's also an easy way, even if you not very, you do not know our library or data visualization, it's an easy way to discover it step by step just by using your code editor and auto-completion. Finally, as we propose a multi-platform library, bootstrapping can be a bit of a pain in the ass because you don't bind your visualization the same way on an Android application or on a web page. So here you can see we have a full visualization with our main class, main function here. This here is all common code, pure common code. You can run this on any platform, you will have the same result. And so we add some extension function specific to the platform. Here, this function, bind renderer on, is only available in the JavaScript platform. It allows you to bind the visualization you have created to a canvas on your web page. Okay? So we have the same type of function for JavaFx or Android, which allows you to bootstrap your project very, very easily. Now Gaetan will talk to you a bit more about architecture. Thanks.
So now let's see how it's done internally. So let's go back to D3.js and to see how it's working. So this is the code that user developer is calling on the D3.js API. So there is this select element, append element, attribute, and under the hood, D3.js is going to call these functions on the browser API. So he is going to create an element circle, and he's going to create and to call the set attribute on the newly created element. But the name of the attribute is what you passed here. So here, for example, if you passed radius, it's not going to work because the normal attribute of a circle in SVG is R. So it put the pressure on the developer to know exactly how what is the grammar of SVG, and it's not very easy to use. So when we did the porting of the library, the first thing we did was to put some abstraction over it. We kept the mechanism, but we just put some abstraction over it. Because we think that when you use D3.js or you use a library like that, your goal is to create that visualization. So it's better to guide the developer and to give him all the APIs that will help him to be really productive. So what we did was to create this circle interface, for example, and this circle interface was in the common code, and then we provided a circle DOM implementation for the JS version of the library. And so we didn't use the R attribute, but we used the radius, and now it's a property on the circle interface. And when the developer is assigning the value 50 to the radius, under the hood, it's the circle DOM class that is calling set attribute R, and it's doing the changing and using the right attribute name on the DOM. And this has worked quite well. I mean, we could do that on all the basic elements and port all the D3.js module with that mechanism. Then we started to work on JavaFx. And it was quite easy because JavaFx is working nearly the same. By that, I mean that SVG has a circle, rectangle, path, text, and I don't remember what. But JavaFX has exactly the same kind of objects. So there is a circle inside JavaFX. And so we could just propose another implementation of the circle interface and do the delegation to the circle object in JavaFX. What you have to notice with the first design of D3.js is that D3.js is not holding any state. The state stay in the platform object, so in the DOM or with our implementation, it was inside the JavaFx objects. So it was just delegating the call to the platform object, but not keeping the state. And then we had to work on Android. And when we started to look at Android, I was a little bit puzzled by the APIs, and I didn't find my object. I wanted to find a rectangle, a circle, and there were not object like that in Android. I had the chance to had a discussion with Romain Guy during a last MixIT conference in Lyon, and he told me, well, you can re-implement SVG using Canvas. It shouldn't be too complicated. So that is the design that was proposed. It was to say, okay, let's create a circle SVG class, which is going to own the state of the circle, so its position, its size, its radius, etc., and then use a rendering functions to render this circle on a canvas. So it was doable, but I thought at that moment that this code was common code. I mean, it wasn't specific to Android. So we could reuse that code and put that code in the common part and then reuse this design. So this is what we've done. So we moved the circle from the platform part, and we moved that into the common part of the code. And so now it's no more an interface, but it's a class, a data class, which holds the state of the circle. And then we use the exactly same mechanism on all platforms. So we use renderers on JS, on Canva, on JavaFX, and on Android. And we have those renderers, and we have to now to manage the rendering. So we call a function render my visualization to this canvas. So, which is interesting is that now we have something that is much easier to understand. I mean, we have a root object which is a visualization, a viz, and then a viz has a layer, at least one layer, and it has group, circle, rectangle, path, text, etc. But with these very small basic objects, you can do all the visualization you want. And now it's really memory. It's all the visualizations stay in memory. So the algorithm are working in memory on those objects, and at one moment we just decide to render them onto Canvas. So it's quite easy to think about, to understand. So with the current version, we have renderers for JS, JavaFX, and Android. And so the next version will be an iOS renderer. And maybe we could do a WebGL renderer if we think it has more performance. It could be interesting for maybe a WebAssembly version of it. OK, so now let's talk a little bit about what is the work that you have to do when you do multi-platform development. So one big part is aligning APIs. By that, I mean that you want to have the exact same behavior on each platform. And for that, you need to use what is available on each platform. So for us, the goal was to have the exact same rendering. And it starts with the coordinate system. So the coordinate system is the same on each platform, but then you have to deal with the angles. And so now, at that moment, it starts to be a little bit more complicated. So JS is using radians, and they are clockwise they are positive in a clockwise direction. When you use JavaFx, it uses degrees, and the direction is the opposite. And when you are using Android, it's also different. So it's degrees and clockwise. So that's not a big problem, but then come the APIs. So to draw an arc on JS, you have on the context of a canvas, you have this function arc, which takes the center of the arc, its radius. the start angle and the end angle and the direction of the arc. When you do JavaFx, you have the center of the circle. You have so you have two radius, one on the x-axis and one on the y-axis. And now you have a start angle and a sweep angle. So you start at -45 and you do 85 degrees. And on Android, so the name of the function is not arc. There is no arc. You use arc2, and now you use a rectangle, the rectangle that is the bound of the arc, and you also have a start angle and a sweep angle. So you have to do all the mix of these APIs to be sure to have exactly the same result. So it's not very complicated, but sometimes it gets you a little bit mad. And sometimes you don't have the function. So for example, there is no arc2 function in Android. On Android, the arc2 function is the equivalent of arc, and it's not an arc2. So you have to do the math. So you have to take your trigonometry and go back to the basis and just calculate all the needed stuff, the needed point to do the drawing. Testing. So as you understand, there are a lot of differences on each platform. So you have to be sure that it's going to work exactly the same way. So the first part of the testing is about common code. And this is working really well. I mean, we didn't have any kind of bad experience on it. When you write common code, you can write common tests. And those tests are going to be executed on each platform. And we never had bad experience on that. So kudos to the JetBrains teams. It works really, really well. Then you have to test your specific platform code. And now it's started to be difficult because you are going to add the complexity of each platform in your building test. So for example, for us, what we had to do was to say, OK, I had a visualization, and I'm going to render it on each platform and get an image of it, and then compare the images to be sure that we have exactly the same rendering. So on JS platform, we used Puppeteer, which is an API that gives access to a Chrome headless browser. So you can launch a browser. So here we launch a browser with visualization, the renderer, and the renderer so creates canvas and image inside the canvas. And then we use Puppeteer to do some selection on the canvas element inside the page. And Puppeteer has a screenshot function that can take a canvas and just do a screenshot of the element. So at the end, we have a rendering PNG file. On JavaFx, it was quite easy because we just had to run some tests inside JUnit, and the canvas of JavaFx has a snapshot function, and we just had to save the result in a file. And on Android, it was, again, a little more complicated because when you want to do some integration tests on Android, you have to use an emulator. So we use ADB to launch the test inside the emulator. And the test, our tests were storing the file inside the emulator. So after you have to pull the file from the emulator to the testing system. So you have to call ADB pull and copy the rendering PNG file inside the testing system. So here, for example, a test. So we have a test. We declare the visualization of the test. So it's a very simple test. But for this visualization, we do the rendering of the 3 images and see. So I just did a modification to have a difference. So here we see that the second image is different on the JavaFx renderer. Okay. And then we compare the images. So we use another tool which is called D3.js, and it does some pixel-to-pixel comparison. So when there is a problem, it indicates the resulting difference. So here we have a lot of difference between this image and what we wanted to have. So this is the result. We see that we have 10,000 pixels that are different on this image. And we just have to give a threshold where the test is failing, because we have some minor differences because of the anti-aliasing system, which is different on each platform. So if, for example, the test failed because of this image. So what is the current status of the project? First, some statistic. We have nearly more than 40,000 lines of code for the library. We have 12,000 lines of code for the test. And what is really interesting is that we have more than 95% of code which is common code. So the very specific part, we could keep it in a really small part of the code. So it's really interesting because now we can add iOS and it will not be a big effort, and we will have all the work we already done. So we just released the version 0.7. It's the first one which has Android support. Now the design of the new design is available for all the platform. We just removed the old code that was using SVG and JavaFx. We are using Canvas, and we have about 90% of the features of D3.js which are available now. The library is available on Maven Central, so you can really use it easily. You just have to put the dependency on the root project, and you can run your code really easily. The next version will be focused on the event API to be sure that we have the interaction of the user can interact with visualization in the same way on each platform, to do some drag and drop, to do some selection, stuff like that. We'll also add some text features like managing the font styles, font family, stuff like that, to provide a way to use multi-line text. And we also want to have some editable online tutorials so that we can explain really simply the concept and to be able to run it and to see the result just under the code. And to make some modification and see the result of the modification. We're also going to work on some plugins. And the first one will be just to bootstrap the project and to help people start with the project to the correct selection of the dependency and stuff like that. So now, we've been working on that project for a year and a half. We didn't do only that, but we started a year and a half from now. And at one moment we said, okay, well, now we must earn a living, because it's good to do open source code, but at one moment you need to earn some money. So we had few options, and one option was to do some consultancy on the library and say, okay, we can help you build nice data visualization. But we didn't choose that option because we thought it would slow down the work we were doing on the library. And the other option was to create a product. So we created a product on the top of the data visualization library. So this is charts.kt, and it's a multi-platform library to do charting. So Data2Viz is a kind of the open source library Data2Viz is to create all the visualization you can imagine, but some people don't need to do all the work, and we thought that we could provide a way for people who just want charts or don't want to spend too much time to learn data visualization. For them, we created this higher level library, and which gives more productivity when we're just creating charts. So this is an example of it. So the idea is, I have to drink a little bit because I won't be able to finish. The idea is to propose a DSL in which you give only what is mandatory, and the library itself is managing all the rest. So it's managing the axis, for example. There is almost nothing on the axis. It's managing the scales, the colors. So here are the colors by default. It's managing the sizing, the padding, etc. And here we just have to define in the DSL what is specific to these charts. And all the rest is done by default. And if you want to change something, you go in this DSL and you make the change. So for example, here, I want to access a specific attribute to put some grid lines. So I go in the y-axis, I access the configuration of the y-axis, and I just give another value for grid lines, which by default is false, and I change that. If I want to have some alternate background, I just add another line. And if I just want to change the way it's rendered. So here I want to use stack column chart. So I just go on the stacking, set the starting attribute, and set it to stacking normal. So what is really interesting here is that with this DSL, Kotlin DSL, we have something that is pretty much declarative. So when you look at the code, it's like declarative code, like just configuration code, but in fact it's really some code with some a lambda for more dynamic part. So it's really easy to create some charts with that. So we have a demo which is online, so you can go on the Play Store and load it, and there you will see all the kind of charts you can do with this library. And we created a special site for it, so it's chartscatted.io, and there you will have access. We have an early access program, so you can apply now. And you will have a lifetime license. The idea is to propose the same kind of license than other charting library like HiCharts, for example. So you can already go there. So I think we talk about everything. So here are some links. This is the GitHub repository of the open source library. We are open to contribution. There is still a lot of work to do, so don't hesitate if you want to work on the Android part, on iOS. Welcome. It's difficult to be expert in all those platforms, so it's interesting to have people that comes from maybe Android or iOS. And these are the other websites. So thanks a lot, and if you have questions, we can answer it.